Hello friends, in this video we are going to study the fundamental tool of calculus which is highly used in almost all programs of engineering. The daily life example I am giving, if you are coming to college by your own vehicle, there are various factors or you can say the variables, you can say the parameters. If time is the parameter, speed is the parameter and the traffic density is the parameter. And if we consider these three parameters, time t is a function of speed and the traffic density. And what I am going to do, I am going to keep traffic density constant and I want rate of change in time with respect to speed. As speed changes, time may reduce, speed decreases, then time increases. But if I want to calculate the rate of change in t, time, with respect to s, then in this case, the tool is being used, which we are going to study. The prerequisite of the tool is limit and derivative. In short, the limit is what? The limit of any function is equal to L when this xy tends to AB. And when this approaches to AB, the value of the function is L. This is what called the limit. This is limit. Now, what is derivative? In earlier years, you might have gone through derivatives. Graphically, I tell you first. Derivative represents the slope of tangent. So this is the curve. This point I am going to take. And this is the tangent to this point. Let this point be P. The slope of the tangent is derivative of this function. Y is equal to fx is a function. Suppose the derivative of y is the slope of the tangent at this point. Now, this x and y axis, if I take horizontal line, the slope of the horizontal line is not there, means the slope is 0, because that line has no slope. In horizontal line, y remains constant and x being varied. When y is constant, the derivative of the constant is 0. The slope of the tangent of horizontal line is 0. So this curve I am going to draw, and at these 2 points, point P and point Q. Okay, these 2 points are very closer to each other. The coordinates of the points are xy and coordinates of this point, the x delta x plus y delta y. What is delta x and delta y? It is delta x is a small increment in x and delta y is a small increment in y. This much distance is very less. Now, this much distance is y plus delta y. This much distance is y. Therefore, this much distance is this one. Is y plus delta y. This is y, this is delta y, and this is x, and this is x plus delta x. So this much is delta x. And what I am going to do? I am going to take the ratio of these two, ratio of delta y and delta x, and the limiting value of this ratio when delta x becomes 0. So this is what called the derivative of y with respect to x. This is derivative of this curve y with respect to x. This curve is y is equal to fx. The derivative of this curve at the point P is what? dy by dx is. Now, how to calculate derivative of x square? Here I am writing find the derivative of x square. Let y is a function of x means y is equal to x square, and the derivative of x square is 2x. I am going to explain the definition of the derivative. So I will be using definition of the derivative here. The definition of the derivative I write limit as h tends to 0 f of x plus h minus fx this divided by h. This is derivative of fx with respect to x and I am denoting it by f dash. Y is equal to x square. It is known to you. F of x plus h means f of x is x square. Y is equal to fx. F of x is x square. The f of x plus h is what? X plus h whole square. The value of f of x plus h I am putting. F of x plus h is x plus h whole square minus fx is x square. This divided by h. When you open the brackets, just I am going to open it. This is x square plus 2xh a plus b whole square formula, a square plus 2ab plus b square plus h square minus x square. This divided by h. Now, this x square gets cancelled and 2xh divided by h and h square divided by h I am writing here. Limit h tends to 0. 2xh divided by h means 2x plus h square divided by h is h. Now put h equal to 0, so you are getting 2x here. So in this way, we found derivative of y with respect to x. The definition of the derivative now, I think it is clear to you. This point is xy. The coordinates of this point x plus h and y plus h. Then this much distance is x. This much distance from the origin is x plus h, means this is h only, and this much is y. Therefore, this much distance is h again. Now, the f of x, function of x plus h minus of fx divided by h and its limiting value when h decreases to 0, when h is approaching to 0. Okay, that is what called the derivative of fx with respect to x. And here we have calculated the derivative of x square with respect to x using definition. Now, I am talking about the partial derivative. So what is partial derivative? If y is a function of several variables, derivative of y with respect to one of those variables keeping other variables constant, that is what called the partial derivative. Now, the definition of partial derivative, I tell you, we started discussing partial derivative. What is a partial derivative? It is the derivative of a function of several variables with respect to one of those variables, keeping other variables constant. This is partial derivative. Thank you very much.